Hello friends, welcome again. Today I shall explain you the solubility trends of various compounds. In this video, I will explain you the trends in the solubility of the various compounds once we are moving across a period or once we are moving down the group in a periodic table. So let's get started. Okay, so larger is the difference between size of cation and anion, larger is the solubility and vice versa. So what you have to remember, so if the difference between the size of cation and anion is large, the solubility will be large. And if it is smaller, the solubility will be smaller. In order to understand this, I have given here some anions which are larger in size. So these include carbonate, nitrate, sulfate, perchlorate, oxalate, and iodide. These anions are bigger in size. Okay, these are the anions which are smaller in size. These include fluoride, chloride, oxide, and hydroxide. In order to understand the solubility pattern or solubility trend, we are being asked here a question, write solubility order of various compounds. So the compounds are beryllium carbonate, magnesium carbonate, calcium carbonate, strontium, and barium carbonate. Which of these is more soluble and which is less soluble? So in these compounds, the anion is same, that is carbonate. And we know carbonate is large sized anion. So I am drawing here the carbonate. These are represented by blue spheres. These are equal in size. Okay, now cation here is beryllium ion. Here magnesium, calcium, strontium, and barium. And we know beryllium cation is smaller in size, whereas barium cation is larger in size. So I am representing these cations with the help of these red spheres. You can see here beryllium is smaller in size, magnesium is a bit larger, calcium cation a bit larger, and barium cation is largest in size. Okay, what we have to do? We have to see the difference between size of cation and anion. So here barium cation is larger in size and carbonate anion is larger in size. So both cation and anion are larger in size. So difference in the size of cation and anion is very small in case of barium carbonate. So if difference is small, solubility is also small. On the other hand, if you look at beryllium carbonate, here beryllium is smaller in size, whereas carbonate is larger in size. So difference in size of cation and anion, it will be larger. So accordingly, solubility will be more in case of beryllium carbonate because difference in size is more. So solubility will follow the order. Beryllium carbonate is soluble, it is having highest solubility, followed by magnesium carbonate, then calcium, strontium, and least soluble is barium carbonate. Okay, using this idea, we can predict the solubility trends of alkaline earth metal compounds. So what are alkaline earth metals? These include beryllium, magnesium, calcium, strontium, barium, and radium. I am showing you the compounds of carbonates, nitrates, sulfates, perchlorates, bromides, hydroxides, oxides, and chromates of alkaline earth metals. So coming to first part, carbonates of alkaline earth metals. So if we will look at beryllium carbonate, beryllium is smaller, carbonate is larger, so size difference will be more here. On the other hand, in case of barium carbonate, barium is bigger in size, carbonate is also bigger in size, so difference in size is less in barium carbonate. Since the difference in size is more in beryllium carbonate, so beryllium carbonate is having maximum solubility, whereas barium carbonate is having minimum solubility. So solubility will decrease if you move from beryllium carbonate to barium carbonate. So this is the decreasing solubility order as we are moving from beryllium carbonate to barium carbonate. In case of nitrate, since nitrate is also bigger sized and beryllium is smaller sized, so difference in size will be more in case of beryllium nitrate as compared to barium and nitrate. So solubility will again decrease as you are moving from beryllium nitrate to barium nitrate. And same is the case with sulfates, chlorates, and bromides. In case of hydroxide, since hydroxide is smaller in size and beryllium is also smaller in size, so difference in size is very less and solubility is less. On the other hand, in case of barium hydroxide, barium is larger in size, hydroxide is smaller in size, so difference in size will be more in case of barium hydroxide. So barium hydroxide is more soluble, whereas beryllium hydroxide is less soluble. So solubility will increase from beryllium hydroxide to barium hydroxide. And same is the case with oxides, because oxide is smaller in size and beryllium is smaller in size. So difference will be less. Okay, as per chromates are concerned, as per beryllium chromate is concerned, it is larger anion and beryllium is smaller. So difference in size is more. It is having more solubility, and down the group solubility will decrease. Okay, now we will discuss the solubility trends for alkali metal compounds. So alkali metals include lithium, sodium, potassium, rubidium and cesium. So we shall be discussing these compounds, the trends in solubility of alkali metal compounds of carbonates, nitrates, sulfates, perchlorates, bromides, hydroxides, oxides, fluorides, chlorides and iodides. Let's start with perchlorates. Since perchlorate is larger in size and lithium is smaller in size, so size difference will be more, so solubility will be more in case of lithium perchlorate, and down the group solubility will decrease. Since bromide is also larger in size but lithium is smaller, difference in size is more, solubility is more. Whereas in case of cesium, bromide, both are bigger in size, difference in size is less, solubility is less. So down the group solubility will decrease. As per hydroxide is concerned, hydroxide is smaller in size, lithium is also smaller in size. So size difference is less, solubility is less in case of lithium hydroxide. Whereas in case of cesium hydroxide, cesium is larger in size, hydroxide is smaller in size. So difference in size is more, so solubility will be more in case of cesium hydroxide. Means down the group solubility will increase. As per oxide is concerned, oxides are also smaller in size. So same trend will be followed here. And same will be the case in case of fluorides and chlorides because these are smaller sized anions. As per iodide is concerned, it is bigger anion and lithium is smaller cation. Difference in size will be more in case of lithium iodide. So its solubility will be more. So down the group solubility will decrease. Now as per these three are concerned, carbonate, nitrate and sulfate. We know carbonate, nitrate and sulfate, these are larger sized anions and lithium is smaller sized cation. So difference in size is larger. So we expect that solubility should be more in case of lithium carbonate or lithium nitrate and lithium sulfate. Whereas in case of cesium nitrate, whereas in case of cesium carbonate, cesium nitrate and cesium sulfate, both are bigger. So size difference is less, solubility should be less. So solubility should decrease down the group, but it is increasing. So these three are the exceptions to this rule. So you can mark these as exceptions because these are following the reverse trend. So thanks for watching this video.